This video is going to talk to you about sampling and how you can sample a population to make predictions about a larger population. So these notes we've already taken on our note sheets, but just to review, sampling is used to make predictions about a large group of people. And sampling is typically used for politics, sports, and business applications. To make a prediction, a small group of people is asked to answer a question. So for example, in the project that you're doing, you're going to ask 25 people to answer your question. And then you're going to use that to make a prediction about the larger population at PCTI. So you're going to use that small sample to accurately make a guess about how many people in the large group would answer the same way. So that's what sampling is. Now we're going to get into how you can actually use your sample sizes to make a prediction. So the best way to do this is by setting up a proportion. So you've seen proportions before. They're used to compare two equivalent values. So on the bottom of your second proportion is always the total population. So that's the population you want to make a prediction on. And again, the group we are predicting for. So you do want to write this down on your note sheet so that you have it for the project. That's, again, the total population is the group we are predicting for. And then the top of that, the bottom of the other fraction is the total sample size. So if we're going to use the example of our project, the total sample size that you're asking is going to be 25 for the people that you are asking your question to. The total population is going to be the number of people that go to PCTI. So we're going to use the number 3,300. But again, those are the bottom of the fractions. They're always totals. One is the total of the sample size. The other is the total population. The total sample size will always be the smaller one. Then the next thing on the top of this fraction is going to be the number of people who answered yes to your question. So for example, if your question on your project was, do you like dogs? And 13 out of 25 said yes, the number of people that said yes, which is 13, is going to go on top, and our sample size is on the bottom. And then for the other fraction, this is going to be what we're looking for. So this is the prediction we're making. And if you remember from algebra, when we don't know a value, we use x in its place. And x is going to be our prediction. So when we solve for x, we find out how many in the large population we think would answer yes to our question. So at this point, you want to make sure that all of this is written down on your note sheet so you have it for further reference. Okay, so if we look at an example, it says in a community of 64,000 people, 84 out of 1,200 randomly selected people responded they prefer sports cars to motorcycles. How many people in the community can be expected to prefer sports cars? So if we look at it, we're trying to predict how many people in 64,000 would prefer sports cars when we've asked 1,200 and 840 said yes. So if we look from the setup in the last slide, we know that the total population goes in our second proportion, or our second fraction. So that's going to be 64,000. Again, the biggest number usually goes in the bottom of this fraction because the total population will be the biggest number that you have. Then the next thing that you need to figure out is how much is in your sample size. So how many people did you randomly select and ask this question? So in this case, that's 1,200 because it's out of 1,200. So that infers that we asked that many people. So that goes on the bottom of your first fraction. And then we think about how many people said yes to this question. So the people that said yes, that they prefer sports cars, is 840. Another way to remember this is that 840 out of 1,200 literally means the fraction 840 over 1,200. So if that helps you set this up, you can also use that as well. And then the value that we're looking for is how many expect to prefer sports cars in the total population. We don't know that, so that becomes our prediction, which is x. So that's how we would set this up. Then to actually solve the proportion, we're going to use something called cross multiplication. So you've probably seen this in the past, but just as a reminder, what you do is you're multiplying the opposite parts of the fraction. So what that would look like is 1,200 gets multiplied by x, which becomes 1,200x because we don't really know what x is yet. And then the second thing we do is multiply 840 times 64,000. So the reason it's called cross multiplication is because you're literally multiplying across, which makes this x. So when we do 840 times 64,000, we get this huge 53,760,000. Now, this right here actually becomes a one-step equation. So if you remember that from algebra, we're trying to get x by itself. X is connected to 1,200 by multiplication. So you solve using division. So what that would look like is x equals 44,800. And we have 44,800 by dividing these two numbers. So you want to make sure you do that in your calculator and just double check that you can get 44,800 people. So what that means is we predict out of 64,000 people that 44,800 of them will prefer sports cars. So again, that's how we use the smaller population over here that we sampled to make a prediction about a larger number. Okay, so that's the first part of example 1. Now, the second thing you're going to be expected to know is how to do a margin of error. So what a margin of error means is because this is a prediction, we're not 100% sure that 44,800 is going to be the exact number of people that prefer sports cars. So what we do is create an interval where we think it's going to be between. So it's not an exact number, but we were saying like we think between this number is going to be accurate. So in order to calculate the margin of error, the first thing that we're going to do is convert the percent to a decimal. So they'll give you what they want you to calculate in form of percent, and you're going to convert that to a decimal. So we'll see that that looks like in a second. But when you convert to a decimal, you're really just moving the decimal places to places to the left. So again, we'll look at that in a second. The next step is we're going to multiply the decimal by the total population. So the total population they give you in the problem, you're going to multiply that by the decimal. Then the last thing you're going to do is you're going to add the margin of error to your answer and then subtract the margin of error to create an interval. So again, we're going to look at this in a second, but really the idea is we're finding out how far we think we're off, and then we add and subtract to create an interval. So if we look at this in terms of the first problem, it says estimate an interval for the number of people that prefer sports cars if their survey has a margin of error of 4%. So like I said, they give you that as a percent. So our first thing we need to do is convert that to a decimal. So if we have 4%, you can either divide this by 100, which is the opposite of when we used to convert to percents, or you can move it to the decimal places 2 places to the left. So what that would look like is the decimal places after 4. So if you move it 2 to the left, it adds a 0 in front and it becomes 0.04. But again, you could have gotten this by dividing 4% by 100, and it would have also given you 0.04. Then our next step is to take 0.04 and multiply it by the total population. So we have the total population from the original question. So we're going to take 0.04 and multiply it by 64,000. And again, 64,000 was our total population from the first part of the question. When we get that, we're going to get 2,560. So what that means is this is our margin of error, and we think that we're going to be off with our prediction by about 2,560 people. We don't know if our prediction is going to be lower or higher. So the next step, step 3, is to create an interval. So we're going to take our prediction, which is what we found x in the first problem. So we found that x was 44,800. So we're going to add our margin of error to 44,800 and get 47,360. And then we are going to subtract our margin of error from what we had as x. So we would get 42,240. So again, we're taking our answer from part 1 and adding our margin of error and subtracting our margin of error. And what this does, once we have those two numbers, we can create an interval, which an interval is like a range of numbers we think it's going to be between. So our margin of error interval is going to be about 42,240 to 47,360 people prefer cars. Prefer sports cars. So again, overall, what we did was we found x, then we found our margin of error, and then we created our interval using those numbers.